This short little video is on solving equations that involve absolute value. Now we're going to return to absolute value in another section and look at inequalities involving absolute value. But for now we're just going to look at equations. So let's just, as a reminder, the absolute value we're going to define. The absolute value of a number represents its distance from 0, and it doesn't matter what direction. So let's consider the equation, the absolute value of x equals 2. So let me mark 0 here. Here is 2, but here is negative 2. Isn't it true that the absolute value of 2 is 2, but also the absolute value of negative 2 is also 2? Isn't that true? So in this case, the absolute value of x equals 2 means that x can be 2 or negative 2. It can be either one of those things because both of those work when you put them between absolute value bars. So to solve absolute value equations, this is what you keep in mind. When you have the absolute value of some quantity is equal to some number, we're going to split this into two pieces. So here is what it means. It means that the stuff inside, 3x minus 1, notice the bars are gone, is equal to the positive of 2, or the stuff inside, 3x minus 1, is equal to the negative of 2. And that's all there is to it. And then you just solve those easy equations. So we're going to add a 1 here. 3x equals 3. We're going to divide by 3, and I get x could be 1, and that would be a true statement. Or here I'm going to add a 1, and I get 3x equals negative 1. And I am going to now divide both sides by 3, and I get, or x could be negative 1/3. Now what I want you to do is to take a minute, you may have to stop the video, and I want you to put 1 back into the equation. That's an easy one, and we'll just do that one. 3 times 1 is 3, minus 1 is 2, absolute value of 2 is 2, so that one definitely works. But I want you to check negative 1/3 because you're going to find that it also works in this equation, and the reason is because once you put in negative 1/3 in for x, you're going, that's negative 1/3, you're going to get the quantity inside is a negative 2, and the absolute value of that is also 2. So either one of those answers are going to check. Let's look at B. Now before I can set it equal to plus or minus 7, I have to isolate, so isolate what's in the absolute value bar. So it's not going to be a 7 because I have to subtract a 2. The 2 is not part of the absolute value. So absolute value of 2x minus 3 equals 5. And now I know that that means either 2x minus 3 equals positive 5 or 2x minus 3 equals negative 5. So don't do it with the 7. You've got to get that absolute value piece isolated. So you've got to get that 2 on that other side, that negative 2. So here I'm going to add a 3. I get 2x equals 8. We divide by 2, and we get x equals 4. That's one of the things that will work in here. Here I'm going to add the 3, and I get 2x equals negative 2. I divide by 2, and I get, or x equals negative 1. So either one of those will fit. Now this last one is kind of unusual. So it is an equality, there's equals, and the absolute value has already been isolated. So I'm going to say either x squared minus 26 equals positive 10, or x squared minus 26 equals negative 10. I'm following the same procedure. Here I'm going to add a 26, and that's going to give me x squared equals 36. Now how do I solve that? I take the square root of both sides, and I get x equals plus or minus 6. So I got two answers there. Here I'm going to add a 26, and I get x squared equals 16. Again, take the square root of both sides, and I get x equals plus or minus 4. So if I list those out, we really have 4 answers: -6, -4, +4, +6. I did them in order. So you can show it like this, or you can show it as one big list. So remember, with absolute value equalities, just take the absolute value once it's isolated, take the stuff out, and set it equal to the positive of the number and the negative of the number.